All right, so here we go. Consider this sequence that you see here. We're continuing our discussion with sequences. This sequence says 3, 5, 7, 9. What do you notice that is interesting or any patterns that you see in this sequence right now? So check this out. To get from a 3 to a 5, we got to add 2. From a 5 to 7, we got to add 2. 7 to 9, we got to add 2. Well, this is a special type of a sequence. This sequence is called arithmetic. So we're going to define these right now. So an arithmetic sequence, so the definition for us is a sequence with a common difference. Okay? And we're going to call that difference a D. So an arithmetic sequence is a sequence that has this thing called a common difference. So what do I mean by common difference? Well, I mean that if you pick any term, let's say I pick the fourth term, and I subtract off the previous term, the term before it, I would have to get a constant every single time. So that constant in this case would be 2, right? Pick any term, subtract off the one before it, and we get a difference of 2. So an arithmetic sequence is nothing more than a sequence that has a common difference. So therefore, arithmetic sequences the word is recursive, aren't they? So what do I mean by that recursive? What does that mean? Yeah. So the next term in the sequence, a sub n plus 1, is equal to whatever the term before it was plus the common difference. So this right here is one way that we can define arithmetic sequences. They are defined recursively, and the next term is equal to the previous term plus the common difference. All right, so next we're going to do, how do we show that a sequence is arithmetic? So I'm going to give you this sequence, a sub n is equal to, we'll do 3n plus 5, okay? We have an arithmetic sequence, 3n plus 5. It should feel arithmetic to you because that's a linear equation, right? So that means that the slope of the line is never changing. So that corresponds to the common difference. It's never changing, right? So if I was going to write out the first 5 terms, what would the first term be in this sequence, you guys? Anybody can yell it out. The first term would be an 8. You're very good. What would the second term be? 11. An 11. Good. How about the third term? What would that one be? 14. A 14. So what do you think the common difference is? 3. So we think the common difference here is 3. So how do we show it? Well, we need to show that a sub n plus 1 minus a sub n is equal to our common difference d. Okay, well that's easy enough. What is a sub n? Do we know what it is? 1. No, what's a sub n? We don't know. Yes, we do. It's right there. It's staring you in the face. What's a sub n? 3n plus 5. What's a sub n plus 1 then? Yes, very good. So this is 3 times n plus 1 plus 5 minus a sub n, which we know is 3n plus 5. All of that has to equal the common difference of 3.
Wait, I have a question.
So this looks like 3n plus 3 plus 5 minus 3n minus 5. Does all that equal 3? Oh my gosh, check it out. 8 minus 5, yep, 3 equals 3. Yeah, exactly. There's a timer up there. Awesome. Okay, I'm giving you a sequence. Here it is. A sub n equals 4 minus n. Please, in your table groups, I would like you to write out the first 5 terms and determine whether or not this is an arithmetic sequence. If it is, tell me what the common difference is. So Stephen got 3, 2, 1, 0, negative 1 for the first 5 terms. And Stephen, do you think this is arithmetic, yes or no?
Yes.
Yes? Why do you think it's arithmetic, dude?
Because with each number, it pretty much the difference is negative 1.
Because the common difference is negative 1. So is the common difference allowed to be a negative number, you guys? Yes. It sure is. No problem. All right. Okay, ladies and gentlemen, this is what I call the fast forward formula, and you'll see why I call it that in a second. The great thing about arithmetic sequences is that they're very predictable. Since there's a common difference between any 2 consecutive terms, we're allowed to do some interesting things with these types of sequences. One thing we can do is use the fast forward formula. Here's what I mean by that. Since arithmetic sequences are recursive, in order to get the next term, I would have to know what? The previous term, and then add on the difference, right? Whatever it is. But wouldn't it be cool if I could just fast forward all the way up to, I don't know, the 23rd term without having to know the 22nd term? Well, it turns out you can, okay? So the fast forward formula, here's what I call it. So a sub n, any term in your sequence is equal to the first term that you're starting with plus the quantity of n minus 1 multiplied by your difference, okay? This is super important. I want to make sure that you understand that this n here and this n here have to match. Those are the same things, okay? So, as an example for us, what would be the 23rd term? A sub 23 would have to be the first term, which in this case is what, everybody? 8, very good. 8 plus 23 minus 1 times the difference of, what is the difference? How do I go from 8 to 11? I add 3. How about from 11 to 14? I add 3. So it's going to be times 3. So that means I'm going to have 8 plus 22 times 3, which means I'm going to have 8 plus 66. So I'm getting 74. Check that out. We are allowed to fast forward all the way up. And we got the 23rd term is now equal to 74. Here is a sequence. Does it look arithmetic to you? It sure does. What's the common difference, you guys? 4. The common difference is 4. I would like you to use the fast forward formula to find the 15th term without actually having to go up to 15. So use the fast forward formula. Tell me what the 15th term is going to be.
58.
Yes, you got 58. How did you do that?
2 plus.
A sub n equals a sub 1 plus, we got an n minus 1 times d. So what do we want? A sub what?
Isn't it 56?
15, right? What's the first term?
2.
Plus, this is going to be 14 times, what's our difference?
4.
4, very good. So that's going to be 2 plus, what, 20, or 56? Yep, very good. So a sub 15 is 58. Do we all agree with that?
Yeah.
All right, so we can fast forward up to get any term that we want as long as the sequence is arithmetic. Okay, so this is an arithmetic sequence. The 8th term is a value of 75. The 20th term is a value of 39. What's the first term? Okay, so check it out. We want the first term of the sequence. That's the question mark. If we skip up to the 8th term, a sub 8, we get 75. If we skip up to the 20th term of our sequence, we get 39. So question, should the first term be bigger or smaller than 75?
Bigger.
It should be bigger, right? Now, because it's arithmetic, it's linear. Therefore, it follows a very specific pattern. So what do we need in order to figure this out? We need the difference. Very good. Remember, a sub n equals a sub 1 plus n minus 1 times d. We're going to use the fast forward formula. Okay? We need the difference. How do we get the difference, Stephen?
I already know the difference. I just how, Stephen?
Yeah, how do we get the difference? Yeah. So what we do?
You set up 2 equations.
Yeah.
Set up 2 equations. There's a much easier way. What is it?
If it's 3, I know what it is.
It's negative 3.
Yeah.
Okay, how'd you do that?
I just subtracted 75, or 39 from 75,
Very good.
and then found the difference of the term.
Very good. Do you guys realize that the difference is the slope? Right? The slope formula, check it out. 39 take away 75 divided by 20 take away 8. So the difference of the term values divided by the difference of the term locations totally makes sense. Therefore, I get a value of negative 3. So we have a difference value now of negative 3. Good. I'm going to use that in my formula here. A sub n is equal to a sub 1 plus n minus 1 times a value of negative 3. Okay, awesome. Now, I need to use another piece of information. I need to either use this information here or this information here. Which one do you want to use? I'm basically taking a point and plugging it back in. Which one do you want to use? The 8 and 75 or the 20 and the 39? 39 and 20. Okay, so here's what we know. We know this, right? We know that a sub 20 has to be a sub 1 plus 20 take away 1 times negative 3. Is that true?
Yes.
Okay, good. Now watch my algebra here. A sub 20 is going to be a sub 1 plus, well, this is just 19 times negative 3, right? Yeah, what is 19 times negative 3?
Negative 57.
Negative 57, right? And what's the value of a sub 20? Do we know what it is?
39.
Oh, we sure do. It's 39. Look how cool that is. So 39 has to be a sub 1, the very first term, minus, what'd you guys say, 19 times negative 3?
Negative
57. Good. So what are we going to do now?
So add each side by.
Very good. So a sub 1 equals 39 plus a 57 for a grand total of
96.
96. Awesome. And doesn't it make sense that this would be bigger than 75? Therefore, it is 96. Okay. All right. We're going to do a very famous math problem right now, you guys. We are going to add up the first 100 positive integers. So I'm asking you, like, what's the sum of 1 plus 2 plus 3 plus 4 plus 5, well, all the way up to 100? Well, what is it going to be, okay? But here's what we did, right? We could just do 1 plus 2 plus yada yada all the way up, right? But that would be kind of boring. Here instead, if I wrote all the numbers out backwards, if I wrote them like here, so if I did like 1 plus 2 plus 3 plus dot 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 plus, I have to end at 100, right?
99.
Plus 99 plus a 98, okay? And then if I add these up vertically, what do I get? 101. How about this one? How about this one? Wait a minute. Plus, these are all going to be 101s, right? Do you guys agree with that? Have I done anything magical so far?
No.
Okay, so let me ask you a question. How many 101s do I have? I have 100 numbers of 101, but then I need to divide by what? 2, because I have 2 rows. I got 2 rows. So if I add all this up, oh my gosh, I get 50, 50, which is the correct answer for the sum of the positive integers from 1 to 100.
Okay, was he just like, I'm gonna make up some new math?
Which led to this, n times n plus 1 over 2. I know, so right, here it is. So we're going to use this formula. This leads us into finding the formula, the first n terms of a finite arithmetic sequence. Now, what does the word finite mean, you guys? Not infinite, meaning it ends somewhere, right? It totally ends somewhere, okay? So the sum of the first n terms, I want to point out a few things. The sum of the first n terms is n over 2. What does a sub 1 represent? What does a sub n represent? The nth term, the last term, wherever you're stopping, right? Okay, let's practice with that. So we're going to add these up. We want to add the first 15 terms, okay? So we want to do it. We want the sum of the first 15 terms of this arithmetic sequence. Well, that's going to be 15 over 2. Yeah, the sum of the first 15 terms, right? Okay, what's the very first term? What's a sub 1, you guys? No.
Wait, why is it 15 over 2?
Right here, right? N over 2. These match, right? Okay. So the first term is
A1 is 5.
5. What is the, remember we're adding all these up, what is the 15th term? It would be 15 would be 33. Yes, very good. So we're going to be 5 plus 33. So the sum of the first 15 terms would be 15 divided by 2 times 38, which would give us 285. So the sum of the first 15 terms of this arithmetic sequence is 285. So check this out. I'm an artist. On the weekends, I'm an artist. This is, I'm going to call this row 1 here. Okay, this is row 1. I'm going to call this row 2. And I'm going to call this row 3. And I've got some tiles here, and I'm making a picture. All right? And I'm going to continue in this picture, in this pattern, all the way down until I'm at row number 10. Okay? I'm at row number 10. So, what I want to know is how many tiles do I need to go buy at the store if I'm going to actually build this at home? Row number 10, if I continue in that fashion.
1, then 3, then 4.
Yeah, very good. How many tiles in the first row?
1.
There's 1. How many in the second row?
3.
How many in the third row?
4.
Plus 4. Good. Okay. I would like to I would like to add up the sum of the first 10 rows. So plus yada yada yada. And then this is going to be a sub 10. How many are there going to be? Sorry. You guys caught me. This is a 5. You're right. You're like, hey, this isn't even arithmetic. That should be 5 tiles there. Sorry. Okay. Take it away, Paige.
First, I use the fast forward formula.
Yep.
To find what A10 was.
A sub 10 is going to be a sub 1.
19.
That's the last one.
So you got 19 for the 10th row. So there's 19 tiles in the 10th row. Okay, fair enough. Then what?
I used the sum formula.
Sum of the first 10 rows is going to be 10 over 2. What's the first term? What's the last term?
19.
Very good. So the sum of the first 10 rows is going to be 10 over 2 times 20, which of course is 100. So I need to go to the store and buy 100 of those tiles if I want to create that picture, okay? Okay, I've given you a short arithmetic sequence. 5 plus 9 plus 13 plus yada 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 plus 49. What's it going to equal when you add it all up? Go for it, buddy. What'd you do?
I basically ended up doing what we did for the one where we had 100
Yep.
so I wrote it the other way.
Oh, you wrote, okay. You wrote 5 plus yada yada yada. This would have to be what?
That's interesting.
That'd be,
Yeah, how did you know? This would be 49, I suppose, right?
Yeah, so
Yeah.
45.
So then 45, right? Then what?
so you find that the total when you add the two numbers up, you get 54 every time.
Yeah, but how many 54s do you have?
Well, I got 12.
How'd you do that?
I did it in my head.
Okay, what'd your head do?
It added 4 every time, so there's a difference of 4
Okay,
in every single time.
I agree with the difference is 4, yeah.
The difference is 4. You can use the fast forward formula, I think, in order to get from 5 to 49. I didn't use it, but I think you could if you were trying to do that.
Okay, so what we need, you're on the right track. Okay, I like how you approach this, but what we need is to figure out how many terms we have, right? So we're going to have to use the fast forward formula. So a sub n equals a sub 1 plus n minus 1 times d. A sub n, do we know that? No, we don't. That's what we're looking for, right? A sub n, do we know the first term?
Wait, we do know
A sub n.
No, we don't.
No, we don't. We don't know how many terms there are, right?
Oh.
Okay, what we do in the first term is 5 plus n minus 1 times, what's their difference?
4.
So a sub n is equal to what?
5 plus 4n minus 4.
4n minus 4, so that means a sub n is equal to what?
4n plus 1.
4n plus 1. Good. So that describes the pattern, right? We have that part right there. And then, don't we know that?
Do we know what AN is?
Yeah, it's 49, right?
Yeah.
How do you know that?
Because it says right there, it's the very last one, right?
The last one you get 12.
12. So,
Yeah.
So 49 equals 4n plus 1. So 48 equals 4n divided by 4. What do you guys get? N must be 6.
It's 12.
N must be 6.
Yeah, I'm sorry.
48 divided by 4?
N must be.
I have 12. So n is 12 terms, right?
Then
Okay.
I used the formula.
Then we use the sum of the first.
Like it's 6. And you're like,
54 divided by 2.
Okay, so we're going to do 12 divided by 2. The first term, 5 plus last term, 49. And the sum of the first 12 terms ends up being 324. So even if I don't tell you how many terms there are, you can use that fast forward formula to figure it out. Okay, ladies and gentlemen, let's head back to our mosaic picture, which is this one here. At the very beginning of class, I asked you guys all to make a guess as to what you thought, how many blue triangles there were, and there are all your guesses here. And even some of you guys guessed again. Connor plus Ross, very good. Okay. So, let's take a look at this. How many blue triangles in the first row?
1.
How about this one here? How many triangles here? 2. How about this one?
All the way to 19.
Okay. How many rows are there?
19 rows.
There's 19 rows. 1, 2, 3, 4, 5, 6, 7, 8. There's 19 rows. How many blue triangles in the last row?
19.
There's 19. So you want the sum of the first 19.
And
The first term is?
1.
The last term is?
19.
Ready, set, go.
they all add up to
Look, we've all refreshed our answer to get the right answer of 190.
the bottom rows. If that was 20,
190, very good. I love you guys refreshed it, very good.